Herzlich willkommen zu unserem gemeinsamen Webinar Best Practice Segmentation and Monitoring in OT Networks. Mit dabei haben wir heute den Neil Wilkins. Er ist Pre-Sales Engineer EMEA bei Garland Technology UK und er wird heute das Webinar halten. Zunächst einmal vielen Dank für die rege Teilnehmerzahl bei dem doch jetzt inzwischen schon besseren Wetter. Ich hoffe, dass Sie heute einen schönen Tag haben und Ihnen das Webinar gefällt. Deswegen in der Hinsicht würde ich jetzt weitergeben an den Neil Wilkins und zu unserem Thema OT Network Segmentation. Neil, are you here?
Yes, I am. Yeah.
Okay, the stage is yours.
Thank you. Good afternoon, everybody. As Christoph said, I'm Neil Wilkins. I'm the technical director here for Garland in EMEA. Just very briefly, from a Garland perspective, we've been in the OT market for a long time now. We have installations worldwide in the distribution of both power, as in gas and electric. We have installations that are on things such as oil rigs and gas rigs worldwide. We have a lot of military installations nowadays, from NASA, the US government, from tanks to UK warships to supporting our F-35 aircraft. And also very heavily involved in power and utilities right across Europe and across the world, whether that power be traditional coal power, gas, whether it's hydro, whether it's wind, a lot of wind turbines just recently, and also in nuclear power stations where we have equipment that's been tested worldwide for use in nuclear. So we are very experienced in a lot of different industries, as I say, from maritime right around the world. If we look at typical OT networks are usually very mature and are flat, with production equipment from multiple vendors. So whilst micro segmentation may seem a good idea at a network level, from the perspective of actually implementing is logistically very challenging. We've got, planning the downtime, the age of the systems that are in place, the different architectures that are in place. There is also a big concern that the security device that we're looking to put in there also needs to provide and prove its reliability. When we look at it, a goal of an OT plant is efficiency and uptime, and people are always amazingly concerned and really badly concerned about how anything is going to be in their network and how anything will be when it touches their network. It's also very noticeable that the plant teams, whether it's in manufacturing or whatever, are not typically aware of the best practice in an IT infrastructure, and are also very reluctant to allow you near their network. So in the 1990s, when we're looking at 30 years ago now, we came along with the Purdue module. So that was on the basis that systems would be air-gapped and inaccessible to any network. Just move forward now and think of it now. Transformation and the way that we work has made this completely impossible, really. Systems communicate across multiple boundaries. The gains that we've gained by that change in the way of we working bring in different attacks and different ways now. So you can look at research from both Dragos, from IBM in the last year or two, which has shown that the attacks on an ICS and OT network are not specifically aimed at the like SCADA type attacks. They are more generalistic attacks that are permeating across the network. So you can, what's to say that a billing system is no less important than the manufacturing system? The problem that you have in one can percolate and make the same difference across there. So the zero trust segmentation is a valid concept, and it still is that valid concept, but we need to understand more now about the transactional flow and the monitoring that is happening inside the systems, more so than anything else. What we do need, though, is that 100% visibility. From the point of view of monitoring, we still require that 100% visibility wherever it is inside the network. That 100% visibility will give me the support to identify and protect the devices inside the network. That's the first stage I need to do. And then afterwards, onwards, the detect and repair and recover are the later stages down the line. So if we look at that converged model and the concepts behind, they still remain valid. The concept there of that air gap and whatever, but now we need to understand that complete visibility inside there. So we need to know where everything is. We need to be able to recognize the risks that are for that particular device, and then the vulnerabilities for the devices at the different levels. Once we can do that, we can then monitor the behavior. When we can monitor the behavior of that, you can then create some form of policy, and then those policies can be triggered automatically for indications of any sort of compromise inside the network. So you do have to understand the transactional flow of what is happening in your network and understand where things are going. Now, wherever I speak to a customer, I usually always say to them, where is the flow of the data coming from and going in your network? And you'll be surprised how many people have absolutely no idea. So if you can't identify the systems that you're on there, and you can't recognize the device, and then you cannot work out what it's talking to and what it should be talking to, those are the first policies that you need to think about before you go any further. So the origins of segmentation, as we know, lie really deep in terms of an IT environment. And really it began a way to improve and monitor the performance of a network through, better limitation of collision domains, broadcast domains, and a containment of traffic on respective subnetworks. But today we've evolved that to significantly support our security practice inside the network. So what we really want to do is more protection is needed in the network, precisely where it's segmented, and zone-specific policies needed to be set up in that area. See, for instance, an accounting system will have a completely separate of policies to an engineering system. And we need to think about those policies inside that network, create the policies, and then monitor individually inside each and every one of those. So the Purdue module, if you've noticed, has now moved on a lot in this last year or two. So the UK government has brought out models where we suggest putting firewalls at various different levels. And in fact, the US government has done exactly the same. Both have said we need to segment further and further and further at these different levels. However, there are still areas that needs to be significantly thought about here. So when we look at these different levels now and the firewalls that they're recommending that we put there, those firewalls are software devices. So a software device, if it's going to have one rule, it's going to have 10 rules. And if it's going to have 10 rules, it's going to have 500 rules. And there's always the issue that you may get the rules wrong in that software device. They also largely are optimized for IT networks. And it's best there's a very limited number of next generation firewalls that sometimes they may be able to identify a few OT protocols. So what that really means is that firewall is not necessarily seeing the OT protocols. It's working mainly on there and can neither act on commands or interpret the commands to see whether the packet is authorized or not authorized. I mean, simply detecting an OT protocol doesn't make anything actionable from a security process. You've got to understand that where the protocol is, it might need to be there. When it flows through, it may not need to be at that next level. So the traditional segmentation we came from, the concept has changed a lot and expanded. So we're, security teams have used firewalls, they've used access control they 10 times use VLANs from a security. Micro segmentation differs. So whilst traditional segmentation is concerned with controlling north-south traffic, in and out of the data center, etc., micro segmentation is concerned with east-west traffic between applications. So we now need to filter and inspect the traffic across zones. So coming back to what I said earlier, that the language of the industrial environment needs to be recognized as well in those relevant things. So Modbus, DMP3, OPC, you name that, we need to recognize there and going through. And then after that, we need to do a deep packet inspection inside there. So it's critical to know that legitimate political protocol commands can be used for illegitimate reasons. And that's what we need to start understanding and looking at the flow of the traffic, where it's passing, and segmenting and micro-segmenting in the east-west side of things inside this environment that we're building now. It's not realistic to believe that OT systems can be completely disconnected from other systems. That's not going to happen at all. It is possible to monitor and regulate the communications that take place. So we segment, we monitor, we regulate, we continuously monitor, we assess, and we put remedial actions into work for the risk. In practice, though, you need 100% discovery and identifying every single process and system on your network. And the only way to do that is to give comprehensive visibility into every device. Garland has always said that you need 100% visibility in any network. And I've added onto these slides a quote that I found from Forbes in January last year that supported that to all. The first step in any goal is complete visibility into any devices in the infrastructure. Then monitor it. Visibility, monitor. First thing, identify and protect it. Second stage is being able to then detect and recover from where we come on from there. So from a Garland perspective, if we go back to that traditional 30-year-old model with only the single firewall at the top, but of course we could now should be firewalling at every individual level behind. From our perspective, from a network tap, we can tap at any individual level within inside that network, whether it be at the control level, at level 0, level 1, whether it be at the boundary between those two levels, whether it can be the operations level or the link between. We always recommend that we tap both sides of a firewall. For the reason being is that, as I mentioned earlier, how do you know that the firewall is doing what you want to do? From a security perspective, I need before and after data. So I need to see what's going through it and come through it. And I need that historical link back from somewhere else to look and be able to see historically that is what's happened. This chain of reaction of actions has happened for me to monitor after that. We then take that into a series of packet brokers. Packet brokers are a way of allowing me to have multiple taps brought into a central location or a distributed location, and then aggregate that traffic together, which allows me to use multiple different monitoring tools. So I can use multiple different monitoring tools, and I can subdivide what I send to each individual tool, whether it is a security tool or whether it's a network performance tool, to allow me to see what comes through. Now, interestingly, in Europe, we see things in lots of different ways to the rest of the world. In terms of how I come into those OT switches, traditional older style switches never had a mirroring port on them. Some of the newer switches do have mirroring ports. Now, in Europe, we see a big trend that people like to mirror from a span port, from a mirror port. We have to remember that that itself is a vulnerability. That port is software controlled. So if it's software controlled, there is an element of vulnerability about it. I know the first thing I would do is I would try and go in there and take over to be root of spanning tree and then see all the network. Now, I can mirror that data out and I can send that out to whatever monitoring tool I want to at the end of the day. However, we have to realize that there is the option for that monitoring tool to also be able to induce data back into my network. So again, you see that many governments worldwide don't allow this to happen anymore, and they want some form of data diode connectivity to limit and stop the option that the monitoring device can be sending back into the switch, whether it is a traditional switch or whether it is an OT switch. We do see this happening a lot in Europe. We do see that happening around, but we need to understand that if you take that route of mirroring directly out of a switch, there is the chance that you can induce data back into your network at any one way. The best practice really from the perspective of if you're going to mirror out of an OT switch is to put a data diode tap in front of it between the mirror port and your monitoring station. That way I can only have unidirectional data directly into my monitoring station, and I cannot induce back in. Of course, the other thing that when you are mirroring from a switch, you are only seeing the inter-switch traffic. You're not seeing the external traffic flowing through. So in terms of best practice, we normally we use switches on the backbone and in the points that we're worried about the transactional flows of data. And again, there we use a tap in that backbone, and we use a data diode tap there as well to stop me actually bringing the data back in to the core backbone. So if I go into that mode, I can now see the core backplane traffic inside my network, and I can then see the internal switch traffic the other way. But there is no option of me inducing traffic back down. This way is more used on larger networks and is used quite frequently across the world, but not quite so much, I have to say, in Europe. In Europe, we do see a lot more people using just the mirror ports of the switches, but there is a realization now that we're having to put a data diode tap on that port. I wanted to show this as an example of really the both options that we can do. A lot of critical networks are a ring-based in the backplane. That ring-based as the core backplane doesn't take many places to tap into it, to be perfectly honest. And by tapping in 2 or 3 places on the ring at the backplane, you can see all of the core data that's going around. And this often happens in power generation plants. Each one of those verticals could be some form of turbine or something that was reporting up to a control system. So if we tap into that backplane there, I can then take that data off in another way. The switches that I have there, I have another choice really. I could either again mirror, and I could mirror out and bring that in via, as I've shown here with a tap, into a packet broker and still have that unidirectional data diode side of things, or I could come down and I can tap my links at a lower level. Now, again, things are very different in this part of the world to the rest of the world. I've drawn here a packet broker, and it's largely accepted that that's what people use. And I've only got a single tool based off the back of that, so I can look at there. If I have just a single tool, I could just bring that back into my IDS system and take number of links inside it. That really is a short-term gain to do it that way, because I can see the data going into that IDS system. But what happens if I want to check what that's doing, or if I want to put another system in the place there? I still end up having to have some aggregation device by the side of it. But there are multiple different ways that people do this and different wants. But from a point of view of best practice is to bring all of this back to a single location, and now allow me to monitor from multiple different tools and multiple different aspects rather than one. We have a product that we use a lot in that sort of scenario. I've shown here a data diode tap that we have that is effectively 4 taps to 1 or 2 uplinks. And that gives me the chance to tap in line between switches and PLCs, in line between multiple different things. It gives me full fail-safe capabilities in case the network itself or the box itself should fail, and allows the network to be running at all times, and then takes data out to 1 or 2 or maybe more monitoring stations at one time. This we use a significant amount, and I've simplified that first drawing again, so that with that particular box, I can tap either side of my firewall. So I can tap either side of my firewall and I can link that out to some sort of monitoring. In terms of the lower part of that network, I can do again exactly the same. I can tap in a box either side of that firewall, bring the data back to the packet broker, or I could use the mirror ports of a slightly different flavor of that box and come off a number of mirror ports and bring it back to a packet broker. one of the things that I didn't say that I should have mentioned earlier on, another large advantage of a packet broker is the more places you move into this network and the more places you want to see the data, you will have duplicate data. There is no doubt about that. You will see some duplication of the data. The packet broker has that capability, if you want it to remove that duplicate data, rather than providing everything back to whatever tool you are and having to put a larger tool in there and worrying about the duplication of data inside there. The other way that we do often use this product is to aggregate on top of taps themselves. So in some lower cost environments and small environments, I can take a tap that is between multiple different either switches, PLCs and switches. I can aggregate that data and I can bring it up to this box, and I can use the other variant of this that stops me inducing traffic back. So I cannot induce data from one of the taps down into one of the lower taps, and I cannot induce data, importantly, from the IDS, from the monitoring system, back in again. So there are multiple different ways I can come into that network and support that high degree of segmentation that I require at different levels. So from the perspective of where we're going, we know that segmentation is still the core building block. It achieves a huge amount of what we need for both reliability, safety, security. The two most important things that we need to own: we need to understand the flow of traffic inside our network. If you understand the flow of the traffic, then you can monitor and put policies in place. If you don't understand that, then you don't know where to start in the first place. So you need to be able to have that 100% visibility. The 100% visibility will give you the source of information. It will allow you to know what is on there and identify and protect it. We then need to be able to recognize the devices that are inside, monitor that device. From the monitoring of that device, we then know the behavioral patterns of that device. And then afterwards, you can create the policies for that. Once you segment your network tightly, then you can start to see everything that comes through there. So that is a 30 minutes or so of overview of different experiences we have of micro segmentation. Christoph, do you know if there are any questions at all?
So there are a couple of questions. So the first one is, in the Garland Zero Trust Critical Infrastructure Architecture, you seem to place your network taps in the data transmission, in the backbone. How do you deal with this being restricted by system certification in many critical infrastructure systems?
So we are certified by many different authorities, Christoph. So we have different certification via different authorities and different ways. So there are a number of different organizations, and we are also prepared for a specific network to go ahead and be certified with that customer anyway. So we do publish different literature on what we're certified, different literature away from things, and we are going ahead. So there has been, for instance, a lot of requests come in from us in this last 4 or 5 months for the maritime industry. And when you look at what the maritime industry are asking for, it's kind of not effective for the taps anyway. They're only just the normal things that you'd expect to be asked for. but yeah, we go along and we're certified for different organizations.
Okay, thank you very much. The next question is VLAN segmentation safe in OT networks?
I would say that you do need to do it. So you do need to segment, and you need to seriously consider segmenting. So if you look at, and I forget the document now, there is a document produced both by the US Security Defense Agency, whatever it's called. There is a document produced by the UK security people and their committees, of which I'm actually a member of one of those committees, that recommends segmentation, but it also recommends not only segmentation at the level of firewalling, but does say that you must have some form of unidirectional transfer in those places as well for the additional protection. And the worry is what's coming in externally into the networks.
Okay, perfect. So we have the next question. Is the Purdue model still relevant?
It is. It's nearly obsolete if we look at it, but the concept is valid. So the model is relevant and it's a good base point to start from. But so we're looking at a 30-year-old model that said the OT network was the crown jewel. Well, it's moved on from that now. Everything needs protection, not just that side of the network. And that's where you need to look back at some of the more the newer reference standards like ISO 95 and I've forgotten the number, IEC 62443. Sorry, Christoph.
Okay, so the next one is, why do I need to worry about being unidirectional when I can configure my mirror port to be unidirectional? And
I think you've just answered that yourself. You can. So some people say, well, okay, why do I worry about it being? I need a unidirectional tap. I need a data diode tap so that I'm blocking the transfer coming in. And some of the later switches actually do turn around and say, yes, I can be made to be unidirectional, but it's software. So if it's software, I'm not saying there is a vulnerability, but there could be a vulnerability in that software. So you do need a physical diode in there to make it a single directional transfer. Likewise, a lot of the IDS systems also say they can be made to only be unidirectional. But again, coming back to what I say, if it's software, at the end of the day, it's down to somebody configuring it or misconfiguring it. And there is always the option that it could well be, I'm not saying there is a vulnerability, but there could be a vulnerability somewhere. There probably will be eventually.
Okay, so we have another one here. What is, from your point of view, the best way of sharing data between shop floor and office environments?
Sharing between the shop floor and the office. Oh dear. Oh, I'm going to go back to an environment that we were working on probably a year to 18 months ago. And when I looked at it, it was a manufacturing plant in Europe that basically the orders came in from all over Europe and they manufactured in 1 or 2 locations for the total of Europe. And they came in, OTY from the IT network through the cloud, back in and back down again. From a security perspective, they had a number of places of vulnerability. So the only really thing you could do was you could segment, you could firewall at those places. But then what we also did in that particular instance was, as I tried to show in one diagram, was go either side of the firewall. And the going and tapping either side of the firewall gave the security people the reassurance that they wanted. And what they always said to me was, the security people, is we like to know history and a chain of events. And if I'm going either side and coming either side of my firewall, I have a chain of events and I have a sequence of events that I can look back at to change anything from there on in. And I think that is probably the right way to do it. You do need to do that firewall segmentation, but you need to look either side of the firewall to ensure that what is going through one way or the other way, and have to check.
Okay, thank you very much. And we have our last question here. A lot of your slides mention an IDS system. What about in small installations? Is there a large overhead then is needed?
There are products around that you find in some of the larger installations. They have two ways of doing it. They either have a IDS system and they then have a slightly different form of system that just does. So if you think of IDS as being level 10 in the system and doing the recovery, the repair, everything, it does the detect, the respond, the recovery. Identify and protect could be stage 1. So if detect, respond, the recovery stage 10 from an IDS, then identify and protect will be the early stage of that. There are products in the market that just do that early stage, much lower cost products that allow you to identify and protect. So we find in certain things like, I'm going to say power grids, they probably have full IDS in main areas, and in sub-distribution centers, they do these lower cost products that allow them to just identify and keep patching and protecting so they know where things are. The other way, which is very common now, is an IDS at a central location and then some form of tunneling, whether that be a GRE or a VXLAN tunnel. So in the smaller sites, you end up with a tunnel and bringing that data back to the IDS system. Now, what we tend to do there is we tag before the tunnel. So I can let the IDS system know that this has come from, say, location 1, location 2, location 3, or whatever. And then I can put some form of tag on the tunnel so that we know where it is. So there are many different ways of coming around it, and there are different options. Commonly, as I say, is to tunnel, and the other way is to use a slightly different, smaller product. The product to think of there runs on a Raspberry Pi, actually, it's that small.
Very much questions. So thank you all for joining us today at our webinar. If you have any questions or anything related to OT security, just reach out to us at info@acquire.com or to Garland Technology directly. And we are happy to hear from you, and we will send you the slides and the recording afterwards. So we will stay in contact, and we thank you very much. Thank you, Neil.
Thank you, Christoph.
Have a nice afternoon, and hear you.